So today's class will be basically whatever we have done till now. It was the theory and some basically derivation part of the projectile motion. Today what we will do, today we will see how those theory can be applied in the real life scenarios, like for the problems, okay, regarding projectile motion and horizontal motion. So what is a horizontal motion? Horizontal motion means you can treat this as half of our that parabolic projectile motion. That means whatever was happening in that projectile motion or the missile motion, if you take half of that, that means just after the time when the missile is at the topmost portion, if you take from that part, then that motion will be our horizontal motion under gravity. So why too late? Let us start. So our first question, let me read. Bob throws a basketball horizontally from a 20-meter height building. So first if I draw it, so here we can see that there is a building and Bob is here and he is throwing what you say, a basketball horizontally at the speed of 2 meter per second. So the basketball was thrown 2 meter per second with speed, with that much of speed, and the height is 20 meter. And Devin is standing, so we know that it will go like this, right? Because gravity is also working, so it will go like this. Or if I show more nicely, so it will go like this. So Devin is standing on the ground waiting to catch the ball. So Devin is waiting here to catch the ball. How long will the ball travel before Devin catches it? How long means you have to find out the time. So you have to find out the time. So here again we can see one thing, that we have two motions. The first motion is that is along your x-axis. So here also I can take a reference of two axes. That is, my first one is my y-axis, that is for the vertical motion, and another one is for my horizontal motion. Okay, so this is for my horizontal motion, that is for my vertical motion. Now horizontally, that means if I take the x-axis in this motion, so I will put one bar here to segregate two of the motions. So the first one is my horizontal motion, and this is my vertical. Now I will write, so this is the procedure, okay, you guys also see this is the procedure of like your approach. So I will write all the data whatever I have. So you can see one thing, that in horizontal motion the initial velocity is this v, right? So the initial velocity, or u, is 2 meter per second. Time is not known. This displacement, that is this r, is also not known. Okay, so I don't know what is my r, I don't know what is my t. What is the acceleration in this case? You can see that this is a contact force. When David throws it, that means when the ball is out of his touch, that time there is no external force that is acting on that basketball. So that means the basketball is now having no force on it. That means the acceleration on the basketball is also zero in horizontal direction. So this is my zero, right? Now if my acceleration is zero, that means this velocity v at this point, like where the bob is standing, and this velocity at that point when the Devin will catch it will not be changed. That means, because see, horizontally there is no acceleration, so the change in velocity will be zero. So you can say that this formula is absolutely valid for this case, that is s equal to vt, or in this case you can write s equal to ut. In vertical case, we can see that displacement is given, that is our 20 meter, our what you say, we know that the acceleration that is working here is g, because it is under gravity. So g is working, which can be taken as 10, or better say 9.8. meter per second square. Okay, and what you know, and you don't know anything else. So initial velocity is zero. High, you know this thing also, that is the initial velocity u is zero, because see, let me give some name of this u prime, because that. So now see, this v, whatever is my horizontal velocity, if I take a component of this velocity along perpendicular direction, that is the vertical direction, so the angle between them is 90 degrees. So you know that the component will be v cos 90. Now you know that cos 90 is 0, so that means my vertical the contribution of this velocity in vertical direction will be absolutely 0, because cos 90 is 0 and it is not contributing in a perpendicular direction. So we have u prime 0, and we have to find out t as t only. Now what I will use here, now let me see how time can be, like how we can get the time. Now using this formula, it's not possible for me to find the time, because I don't know r also. So let me try from the vertical one. So the vertical one, I can always write v equal to u plus at, that means u plus gt. If you see here, then we know that u is 0, so I can find v, but t is also not known to me. So this formula also is not helpful for me. Let me try this formula, that is s equal to ut plus half ft square. Now in this case, ut plus half at square, if I write, you can see that half gt square in this case. So you can see that u is 0, so my this term will be not here, and I can easily find out the time because I know the g value. So it will be 2h by g, and that will give my answer, because it was asked that before Devin catches the ball, how long the ball will be in the air. So this will give me very easily how much how long the ball will float in the air. Now in this case, now once you get t, using this formula you can also get the velocity, vertical velocity with which the ball will go down. You know the horizontal velocity will not change, but the vertical velocity, which will increase because of the gravitation here, will be changed, because vertical velocity here was 0 and because of acceleration it is increasing, and that we can find out using this formula. Also, once we get the time, if we just put the time here, we know the u, that is 2, we can find out the value of r as well, right? So this is the approach you should have. So this one is done. Let us move to the next one. Now in the next one you can see, in ancient wars, heavy rocks are thrown horizontally from the wall as weapons. You know that, right? In many cases, like many castles, they have this kind of technology only. If the initial speed of the rock is this much, how many meters will it travel horizontally from a wall of 25 meters above the ground after 2 seconds? So it's very easy because t is given already. So what I will do, again I will just draw it. So the ball is going, that means the stone is going and dropping like this. I have to find out this range where I am given with this height, that is for my vertical motion, and I am also given with the velocity, that is 3 meter per second. The g value is also given to me, and the time is also given to me. So you can see one thing, if the time is also not given, we can find out the ball, we can find out the time using that one. Now in this case, it is told that if the initial speed is this much, how many meters will it travel horizontally from the where after 2 seconds. Now we don't know that in 2 seconds it will drop or not. So let me find out the time using that method which we have used here. So if we just do that, let me create that one again. Okay, so now you can see that if this is my vertical one and this is my horizontal one. Now the vertical one, if you say that, you can say that u is equal to 0 because I am using the horizontal velocity, but the going down velocity is 0 because this one is not having any contribution in for the vertical one. And the g, you know the value of g also, meter per second square, and we can find it out using our h because h is also 25 meter. So I can write that s equal to ut plus half at square. Now u is 0, so only half gt square, and using that we can easily find out t equal to root over 2h by g. Now if I just do it in my calculator, I can see that it's 50 divided by 9.8, so it's almost 2.258, almost. So that means we can say that it's 2.26 almost. So I'm taking the approximate value up to 2 decimals, this much second. Now you can see very clearly, I don't have to find. So this 2 second is not the time that is given, that is your the time for the whole projectile motion. It's not that, okay, because the time for your whole projectile motion is this much. So be very careful, don't use this t for the sake of your other formulas. So we have to find out r. So I can easily find out r using this formula, r equal to, so I don't have to find out r here, right? Because how many meters will it travel horizontally when after 2 seconds? When it would be r? It would be r when this time I will be using. That means if r equal to ut and I am using this t, that means my initial velocity I know that is 3. And if I use this much, that is 2.26, so I will get almost 776, so I can take it as 8, so this much meter. But I have to find out this thing, that is u is 3 and my time is 2. So one thing you will notice that you may ask me, sir, then why this 25 is there, like why you have done so much. I have done so much to show you that this time 2 second is not your t, that is the time for your whole flight. So only this much is your this much you have to do, that is 6 meter. So this is your result, so these all data are given just to make you confused. So what is our question again? We are reading it. How many meters will it travel horizontally? So you have to say this horizontally, that means the velocity is not changing. So I can use this s equal to vt formula very easily, because there is no acceleration from a wall this meter above of the ground after 2 seconds. So the time is also given. Then when you have to find out s, and the v is also known. So this much is your total math. Whatever I have done, I have just done to show you the correct thing. So this much is your question ka answer. Coming to the next one. A stack of pancakes are dropped off a high-range building. Assuming negligible air resistance, how far will they have fallen in 4 seconds? Use significant figures. Now, in this case, it is not thrown horizontally; it is just dropped. So you have to understand when to what is happening. Dropping means there is no horizontal velocity; only one motion is there, that is the vertical motion. Like before, we are having two motions, one is a vertical one is a horizontal one. Now we are having only the vertical motion. So you can see that the time is given, that is 4 seconds. So I have to find out where it would be after 4 seconds. My g is given, that is 9.81 meter per second square, and assuming the negligible resistance, so air resistance is not there, so this g will be the total effective g only, and we just have to find out h. So we know that s equal to ut plus half a t square, and u for drop is always 0, because from vertically I have not thrown it with force in this direction. So I have just dropped it, so there is no force in downward direction, and that's why we will be having u is equal to 0. That is why initial vertical velocity is 0. So s equal to ut plus half a t square, that ut term will vanish. So I will be having only half gt square. And now I know all the things, like I know everything, so I can easily find out. So it will be 8 into g, that is 8. So it will be 78.48. So one thing is very clear, with only time you can find out easily how far any object will fall. So you can see there is no mass at all. So I think you remember that experiment of dropping a small ball and a heavy ball all together, and to see that both of them are falling together, right? You know that famous experiment, I think, and you can see in the YouTube also with that experiment with a feather and a heavy ball. So as you can see, there is no mass, like no term regarding mass of those objects. So that means at the same time they will fall at the same height, like at the same with same displacement, okay, in this case height. Moving to the next question, we can see that this one, tomatoes are thrown horizontally off the top of a building. So the height is given. Always draw diagrams which will make your problems easier. and the tomatoes are thrown with that velocity 3 meter per second, and what is given, how far will the tomatoes travel horizontally by the time it hits the ground. So we have to find out this r this time. So that time we did not wanted to find we did not want to find range, but it was asked just to find out for 2 seconds, so it was easy. But in this case it told to find out r, that means the, like, see this, how far will the tomato travel horizontally by the time it hits the ground. Whenever it is hitting the ground, that means this t you need, the time for the total flight you need. So time for total flight we can easily find out, right? So again, for the vertical motion we can do very clearly. For the vertical motion, something is happening. Vertical motion, we can see always that our initial u is 0, g we know, so we can see that s equal to ut plus half at square, that means gt square. We can find out t very easily, right? And that the t will be our 2h by g. But in case of, like, why this t is needed, because this t will be for useful for our horizontal motion. Now we know in the horizontal motion the initial velocity is 3, the acceleration is 0, so we can easily find out the r is equal to v into t, that is u into time. Now this time is this time. Why these two times are same? Because by the time it drops from this point to that point, it has reached this amount r already. So that's why this time is this time same. Okay, so we can use now 3 into root over 2 into h, that is our, how much, 50, divided by 9.81. Okay, so if you just find out this, so I'm doing it for you, that is 100 divided by 9.81 into 3, so the result is 9.57 meter. So it will be 5.8 because it was so. Acha, one more thing, if you see something like this, so approximately taking out a significant figure, you can write this easily. Okay, so once this number is more than 5, you can always write this number one digit, like, farther. Okay, you can raise one digit. Okay, moving to this question, you can see here, so this one is your projectile motion. So this is the first projectile motion problem that I am doing today, and the next time we will be doing some complicated problems as well, that is regarding projectile motion. Okay, if a pitcher throws a baseball out of a window with speed 6 meter per at an angle 45. Now you remember one thing, in the last question it was written throw with horizontal axis, like thrown horizontally, but in this case the throw is 45 degree angle, so that means it will go like this and then it will drop like this, right? So in that case it's a total complete projectile motion, so we can obviously split the speed, because in this case theta is not 90 degree, so there will be contribution in two directions. So this theta is of 45 degree, my v is 6 meter per second, so this one will be v cos 45 degree according to our theoretical approach, and this will be our v sine 45 degree. right? And what else is given? And it takes 10 seconds for the ball to hit the ground. So the total time of flight is given, that is 10 seconds. What is the horizontal distance the ball travels after 5 seconds? So that means, see, half you have to find out. So whatever is the range you have, so see one thing, total time is 10 seconds. Now in my last video I have told you the time taken for any projectile object to reach the highest portion, and then the time to for the object to go and hit the ground is same. So if the total time is 10, so 5 seconds means the half of the time, that means to reach from point A to point B, you have to find out the r/2 value, that means the range from this point to this point. So to find that value, what we can do, you have two approaches to do this kind of maths. The first approach is your direct formulation, so that you can do using the formulas. Okay, if you remember the formulas, you can do that easily. But if you don't know the formulas, you can do it slowly also, what I am going to do now. Okay, so you see one thing, that after 5 seconds, that means t is equal to 5, how far the object will go. Let us see that. So we know that in this case also there are two motions, one is a horizontal, one is a vertical. So if I segregate these two, that is my vertical and my horizontal motion, so you can see that in the horizontal motion, always I told you that for any contact force the acceleration will be 0. The initial velocity for horizontal motion is our v cos 45 degree. So we know that cos 45 is 1 by root 2. So if we just do this thing, we can write v by root 2. And we know that when a is equal to 0, we can always write a is equal to vt formula. So in this case, u into t formula. So u is given, that is my v, that is 6 by root 2 into t, that is 5 seconds, because I have to find out the time, the range for 5 seconds. So I can write 30 by root 2. So this math is done. This math is done very easily. But we will obviously try what would happen if I have given you 4 seconds. Same thing, you can just put the value of t here, and you can easily find it out how much it will go horizontally that much time. But the complication will come when I told you to find out the height, what it will achieve at any moment. Like if I say at t equal to 3 seconds, where will be the projectile, that means how far from the ground the projectile will be, find out. So that can be a challenge for you, though it's very easy to do it. Okay, so we can do these things very easily, right, like this. Okay, and try not to remember the formulas, but try to remember the formulas so that you can do the stuff very easily, but try not to use the formula all together, all the time. Okay, because many of the time it will be handy when you know the basic of it, and when you know how to do the derivations. So see that previous video once again if you have doubt, and if you have not mastered it, but that will be very useful to you to solve any kind of problems. So this much for today, and the next class we will be doing some very kind of challenging problems, and any kind of doubt, you are very much free to call me anytime and ask your doubt. So if you have any kind of problems also, like some challenging problems, you can also give me, so that I can also enjoy while doing it, like while solving it, and I can help you a little bit. So bye bye for today, and I will be sending one link to you, and that is your homework basically. You can either copy the question and show me, or you can do it by yourself. Just be fair enough, because it will help you, not me, finally. Try to challenge. So in that link you will see that it's a like game kind of scenario, like multiplayer game kind of scenario. You can like solve the maths, and you can score accordingly, and you can see your position in like national level. Okay, so bye bye for today, and I will see you in my next class.